Alright, this is Geometry, Chapter 8, Section 2, Special Right Triangles. Okay. So we already know that the Pythagorean theorem says that for right triangles, a squared plus b squared equals c squared. And there are certain types of right triangles where, while we could use the Pythagorean theorem, there's a shortcut equation that we can use in order to solve. And one of these type of triangles is called a 45, 45, 90 degree triangle theorem. Forty-five, 90-degree triangle theorem, and it says this: if we have a triangle where the legs are the same, and what this means is that we have a triangle that has 45 degrees here and 45 degrees here. All right, 45, 45, 90. When I add these guys up, they all add up to 180. If this is 45 and this is 45, we're basically talking about, and these two legs are the same. Then we can say that this guy, the hypotenuse, will always be equal to x times the square root of 2. So the 45, 45, 90 degree triangle is an equation saying that if a triangle is a 45, 45, 90, then the hypotenuse is equal to the side of the triangle, or x, times the square root of 2. Right. The book uses s, I use x, same thing. The hypotenuse is equal to the side of the triangle times the square root of 2. 45, 45, 90 triangle theorem. So here, for number 1, they want to know what is the length of a hypotenuse of 45, 45, 90. So, and they said the leg is 5 square root 3. So this is 5 square root 3. This is 5 square root 3. And they want to know what this side is. We know that the hypotenuse is equal to the leg times the square root of 2. Right? So I'm going to substitute x with the leg with 5 root 3. So it's going to be hypotenuse is equal to 5 times the square root of 3 times the square root of 2. Well, 5 times the square root of 3 times the square root of 2. Alright, that gives me 5 times the square root of 6. And I can't simplify that any further, so I'm done. 5 times square root of 6. Remember that when you multiply square roots and there are different numbers underneath, that's the same thing as saying the square root of 3 times 2. Right, so for the next one, they want to know we have a 45, 40, 90, and they give me the hypotenuse. What's the side of the leg? So they give us the hypotenuse. They want to know what these guys are. Since I know it's a 45, 45, 90. Again, hypotenuse is equal to x times the square root of 2. In this case, the hypotenuse is 10. And that's equal to x times the square root of 2. So what happens is I divide both sides by the square root of 2. You have x equals 10 times the square root of 2. Here's the problem with this. In mathematics, we do not like to have the radical in the denominator, the square root in the denominator. So we need to get rid of that. And the way that we get rid of that is that we divide top and bottom times the denominator, which is the square root of 2. Why can I divide or multiply top and bottom by square root 2 over square root 2? Well, if we look at square root 2 over square root of 2, let's say I'm doing that times 5. If I simplify root 2 over root 2, that's really saying that it's 1 times 5. And it equals 5. So I don't really change the numerical value of 5. I just renamed it, basically. So I'm renaming 10 over the square root of 10 by essentially multiplying it by 1. I don't change the numeric value, but I'm just renaming the problem so that I don't have a radical in the denominator. And that is totally legal. So that's going to be 10 times the square root of 2 over, we multiply the guys down here. So that's going to be 2 times 2, which is 4 square root of 2. And I know that the square root of 4 is 2. And I can divide 10 divided by 2, and I get 5 times the square root of 2. And that is equal to the leg, 5 times the square root of 2. Says we have a 100 by 100 foot square. So if we have a square, this is 100. Right, this guy is going to be x, and they want to know what the diagonal is. If I have a diagonal, that's going to cut the 45, the 90 to 90 in half, so that gives me a 45, 45, 90. So again, same equation. Hypotenuse equal to x times the square root of 2. In this case, the hypotenuse is what we're looking for. We have the side, or the x, equal to 100. And they wanted to round it to the nearest foot. So this is going to be 100 times the square root of 2. And that gives me 141.42. And they asked for the nearest tenth. I always do it to the nearest hundredth, but this is going to be in feet. That's the diagonal. All right, so we talked about the 45, 45, 90. There's another type of special right triangle where we don't have to memorize the Pythagorean, and that's the 30, 60, 90 degree right triangle. And with 30, 60, 90, it goes like this. So this is 30. This is 60. This is 90. Okay. Again, I'm not using x, but what I can do is I can say short leg, long leg. So this is 30 degrees. The side opposite of the 30 degrees is my short leg, so SL. This is 60 degrees, so the leg opposite of the 63 degrees is my long leg. And then here's my hypotenuse. Okay. And the hypotenuse is going to be the short leg times times 2. Okay, and my long leg is going to be equal to short leg times the square root of 3. So I have two equations. Equation number 1, hypotenuse is equal to the short leg times 2. And then equation number 2 is the long leg is equal to the short leg times the square root of 3. So everything is based off of the short leg. In essence, the short leg would be like my x. But I've found it over the years that it's easier to call it short leg, long leg in terms of memorizing for people to see it. If you want to just call it x, you can if you want to. You can use x times 2. You can use x times the square root of 3. You can just call short leg x. But either way, it's fine. Okay. So that's the 30, 60, 90. All right. What is the value of f in simplest radical form? Okay. So if we go up here, they want to know the value of f, and they say simplest radical form. So we have a 30, 60, 90. We have that our long leg is 5, and I know why it's a long leg because here's opposite of 60 degrees. So our long leg is 5. This would be my short leg. This would be my hypotenuse. Okay, so they want to find out what the hypotenuse is. So the first part is in order for me to find the hypotenuse, I have to first find the short leg, because the hypotenuse is equal to the short leg times the square root of 2. So to find the short leg, so step 1, find the short leg. And I use that with the equation short leg, since I have the long leg, equals the long leg times the square root of 3. Okay? So short leg equals long leg is, I'm sorry, long leg is equal to short leg times square root. So I know the long leg is equal to 5. I'm looking for the short leg, so I'll call that x square root of 3. Divide both sides by square root of 3. That's cancel, and I get that the short leg, or x, is equal to 5 square root of 3. Remember, we can't have 3 on the bottom, so I'm going to multiply top and bottom by square root of 3. That turns into 5 over 3 times 3, square root of 3 over 9, square root of 9, and that gives me 5 square root of 3 over 3. Alright, so that's my short leg. Okay. Step number 2. Hypotenuse is equal to x times 2, right, which is the short leg. And I multiply that by 2, so it's going to be 5 square root of 3 over 3 times 2, which is 10 square root of 3 over 3. There you go. Alright, so this thing, we have an equilateral triangle. Remember, if it's equilateral, it's equiangular, which means that all sides are 60 degrees. So if we have a line that cuts through here, make it bigger. So this is 60, this is 60. If I have a line here, that's basically the perpendicular bisector, which is also the angle bisector, so this would be 30, and that would be 30. So we have a 30, 60, we have two 30, 60, 90s. And they say, what is the height of the pendant if... so if we had a side, all the sides are 18. Since this is a perpendicular bisector, this is going to be 9, this is going to be 9. So they want to know what the side of this guy is. This is my short leg, this is my hypotenuse, this is my long leg. So I'm going to use the second equation. Long leg is equal to the short leg times the square root of 3. I already have the short leg. So long leg equals 9 times the square root of 3. There it is. They want it to the nearest millimeter. Whoops. So 9 times the square root of 3 is 15.5. 8, 8. Alright, you guys, that is that section. Hope you have a great rest of your day.